Uh, Good morning, students. Good morning, Floria. Good morning, Ruby. I saw Bill was here already, and where is he again? He just disappeared. I will go straight to what we should be doing today. As the time arrives, we start the class. So, where is it? Okay, we are starting with chapter 3 right away. And for today, we are going to look at how to resolve forces into components. You all remember that a force is a vector quantity, right? So a vector quantity means that forces have magnitude and direction. And so it means that if you what am I trying to do here? It means that if you want to add forces, you add them using vector rules of vectors. Let me give an example to you guys. Let's say this is a tabletop. You're on a table. There's a tabletop, for example. And let's say you have a book lying on this table. Let's say you have a book lying on this table. For convenience, I'll make the book as small as possible. Let's say one person pulls the book to the left with a force of, say, 5 newtons. Let's say at the same time, another person is pulling the book upward with a force of, say, 4 newtons. We are seeing the surface of the table, so I don't want to call this up. But let's say the other person is pulling it to that direction, this person is pulling it to this direction, and this is the table top. So the question I ask is, in which direction will the book move? In which direction will the book move? Certainly the book will move in some direction like this, right? Because there's a pull this way and there's a pull this way. Why does the book move in this direction? Because the resultant of these two forces, the resultant force is in that direction. In other words, if we want to find the resultant force, we can take this 4 Newton force as a vector, we put it on the head of this other force here. So the 4 Newton force here is 4 newtons. And the resultant force is going to be from the tail of this vector to that vector, to the head of that vector. What is the magnitude of the resultant force? Since this is a triangle, the magnitude here will be square root of 4 squared plus 5 squared in that direction. All right. So we are able to make these two forces become like one force. So this whole system will be the same as, you have your book and you have one single force in that direction. It's the same as one person is pulling in that direction, and that person is pulling with a force of magnitude square root of 5 squared plus 4 squared newtons. All right. So the book will move in the direction of that resultant force. We are not focusing on finding resultant forces today, but rather we are saying that if we had two forces, one 5 newtons and one 4 newtons acting perpendicular to each other, and that gave us a resultant force like that, which is square root of 25 plus 16 newtons. So it means that we can also say that this single force is the same as two forces. So you can break it into one force that way and another force this way. Okay, this single force was root 41 newtons, as we have seen. We should be able to use that single force to find what is this force and what is that force. Actually, my representation is not correct. This has to look like this. It has to look like this. You have your single force, square root of 41 newtons. And then you should be able to break this single force into one force in this direction and another force in that direction. But this force also, we can put it on this side. We can put that one here also. So what is the magnitude of this force here? What is the magnitude? We can calculate that using, if we know this angle, say this angle is theta, then this force will be square root of 41 cos theta, right? And this one will have magnitude of square root of 41 sine theta. You can always check to see that if you take this squared plus this squared, you should get this squared. Yeah, this squared will be 41 sine squared theta, and this squared will be 41 cos squared theta, which is 41 into sine squared plus cos squared. which is 41, which is equal to that squared. So if you have a single force and you break it into horizontal and vertical forces, we call this the horizontal component. Horizontal component of that force. And this one is the vertical component of that force. Vertical component of this force. So in conclusion, if we have any force, this works for any vector, not only forces, huh? But we are dealing with forces today. If you have any force, if you have, it makes an angle of, say, theta to the x-axis, the horizontal component of that force, if the magnitude of this force is F, then the magnitude of the horizontal component will be F cos theta. The magnitude of the vertical component will be F sine theta. All right? You may have problems in which the force is not going upwards. Let's say you have a force like that. It makes an angle of theta here. The horizontal component will be this. If this is F, this will be F cos theta. And you think of the vertical component as now joining the head of the horizontal component to the head of the first force. So the vertical component will be this one, which is F sine theta. And the vertical component is downwards towards the negative y-axis. So if you are doing your analysis, you may consider it as a negative force if you wish, but it's not necessary. Let us look at some examples. Exercise 3A. I'm going to go through these 4 examples, which should be very easy to get. It says find the components of the forces in the diagrams. Horizontally, specifying whether it is left or right. This will have a horizontal component like this to the right, and that will be 15 cos 40. It will have a vertical component upward, and that will be 15 sine 40. This one will have a horizontal component to the left, which will be 12 cos 55. It will have a vertical component upward, which will be 12 sine 55. Here, this will have a horizontal component that way, which is 8 cos 20. You have a vertical component this way, which is 8 sine 20. And this one will have a horizontal component this way. And this is 21 cos 70. We'll have a vertical component this way. And that is 21 sine 70. Now, when you make this sketch, guys, you can see how I make my sketches. If you this one was actually not very good. If you join the head of this, it will be able to meet this one. This one also will be able to meet this. To give an indication which component is larger. This one should be like that. And this one should end here. It should end here. I did a better job with this one. You can see clearly that the head of those vectors are the same as this one. So from here, you can clearly see that the horizontal component is larger than the vertical component. And for this one, the vertical component is clearly larger than the horizontal component. Okay? Still exercise 1, you guys should do this. I'll give you a few minutes to work on this one. You work on it before I look at it. Okay, I hope that you've done something on that. For this, there is going to be a vertical component there, which is 13 cos 35. And there's going to be a horizontal component like that, which is 13 sine 35. Okay, right? For this one, there's going to be a vertical component like this. That vertical component is 80 cos 65. And there's a horizontal component like that. This is 80 sine 65. Now, you have seen that instead of using cos for horizontal, we are now using cos for vertical. Why? The angle here is stated with respect to the vertical direction. Remember that cos 35 is the same as sine 90 minus 35. So if you use sine of 90 minus 35, you get the same result. The same thing here. The cosine of this angle is the same as the sine of this other angle. So either way, you get the same results. For this, it should be the same thing. You have a horizontal component like that. That horizontal component is 120 cos 110. Remember, you could also say cosine of this angle is the same. Cosine of this angle is the same as cos 110, but cos 110 will give you a negative value. The cosine of this will give you just a positive value. And the vertical component will be 120 sine 110, or sine of this angle also is the same. And for this one, you should have a horizontal component like that. I would actually prefer to use this angle, which is 180 minus 75. So it's 8.5 cos 5 degrees. And there's a horizontal component like that, or vertical component, 8.5 sine 5 degrees. Okay. One more question. This is going to be very useful when we are using, say, Newton's laws of motion with many forces acting on the object. So question 3 says a particle in equilibrium. Equilibrium here means what? I would like to hear from somebody. Floria, what does equilibrium here mean?
It means the particle is stationary or constant.
The particle is moving
Constant or
constant velocity. Or is at rest. It could be at rest. Okay? Can you interpret it in terms of Newton's second law? What does it mean for Newton's second law? It means that
the horizontal component, the resultant force is 0. In the vertical component, yes, the resultant force is also
summation
0.
F is 0. Because the acceleration, constant velocity means acceleration is 0, so the sum of forces is 0. And so in that case, if we say sum of forces is 0, then horizontally it should be 0 and vertically it should be 0. So we would come here, we are asked to look for F and theta, to look for this force and to look for this angle. So we will simply look for all the horizontal and vertical components. F will have a horizontal component here, which is F cos theta. It will have a vertical component, which is F sine theta. And this 6 Newton force will have a horizontal component this way, which is 6 cos 70. It will have a vertical component, which is 6 sine 70. So if the object is in equilibrium, then the sum of forces is 0, meaning that the total forces to the left should be the total forces to the right. So we will have F cos theta plus 6 cos 70 should be 5. This is equation 1. Because we are looking for two things, we have to form two equations and solve them. The second equation should be resolve Now, there's something I didn't write here. When you are writing this statement, it is important to indicate what you are trying to do. So we will use this. This is to say that this statement here means resolve. Resolve horizontally. In other words, it means apply Newton's second law horizontally. And then secondly, we can resolve vertically. Apply Newton's second law vertically. We'll have sum of forces upward should be equal to sum of forces downward. So F sine theta should be equal to 6 sine 70. This gives you equation 2. You can solve equation 1 and equation 2 to look for F and theta. I will write down equation 1 again in a simplified form. So we'll have F cos theta is equal to what? 5 minus 6 cos 70. You can do a quick calculation with your calculator and state the result. 5 minus 6 cos what? Cosine of what again? Cos 70, correct? I have to first see if my calculator is in degrees. It's in radians. Put it in degrees. Now 5 minus 6 cos 70. That gives me 2.9948. So 2.948. That is equation 1. So to solve equation 1 and 2, we can first divide equation 2 divided by equation 1. We will have tan theta equals something. 6 sine 70 divided by 2.948, giving us theta equal tan inverse of that. Tan inverse of that. And to look for F, you can take equation 1 squared plus equation 2 squared. That will give you F squared sine squared theta plus F squared cos squared theta, which is F squared times sine squared plus cos squared. Sine squared plus cos squared will be 1. So that will give you 6 sine 70 squared plus 2.948 squared. So F will just be square root of this squared plus that squared. Okay? I don't know how much time we got left. Should we solve one more question? Let's look at one more problem. 10 minutes. One more problem. Which one should we look at? The last one. Let's look at question 13 and see. Question 13 says a particle has 3 forces acting on it, as shown in this diagram, where sine theta is 3/5. Show that F plus G is this by resolving horizontally, and write down another equation by resolving vertically. Resolving horizontally, that is what I meant by you indicate with this. So you resolve horizontally. So we will have this. It's the same problem we solved before. So you have a horizontal component here, which is for F, it is F cos theta. And for G, it is G cos theta also. And the horizontal component for 240 is 240 cos 30. And then vertically, you have F sine theta, and you also have 240 sine 30, and downwards you have G sine theta. Now we resolve horizontally, we get F cos theta plus G cos theta should be 240 cos 30. All right. Now we are told that sine theta is 3/5. So we have to look for cos theta. Sine theta is, if this is the angle theta, this sine theta is 3/5. So this should be 4, right? So cos theta should be 4/5. So that means if we come here, we'll have 4/5F plus 4/5G is equal to 240 cos 30. What is the cosine of 30 anyway? Cosine of 30 is what? √3/2, correct? Yeah. And now you can simplify this. So F plus G will be 240 root 3 over 2 times 5 over 4. Simplify this and you get 150 over root 3. All right? And then it says you should find write down another equation by resolving vertically. So resolve vertically, we will get G sine theta should be equal to F sine theta plus 240 sine 30. So that is the equation. You can simplify it. Okay. For today, you would solve the rest of the problems in exercise 3A, okay? So question 2, 3 until the end. Okay, and submit on Edmodo. I haven't started a new course for this chapter yet. I'm going to do so soon. Okay, thank you guys for coming. Question? Somebody
No.
ask a question? Floria?
No.
No. Okay. See you guys.
See you.